So in this talk, I want to do something very ambitious. I want to map the landscape of about 2,000 papers. So I'm going to take you on a fast journey. Okay, it's going to be lightning fast over 2,000 papers that have happened in our community. But by the end of this, you will not probably be an expert on refactoring, but you will get a good understanding of what the field has been, where has been the biggest growth. And I subtitle my talk, The Refactoring of the Refactoring, because it's about the change of the field of refactoring. Okay, so understand I'm here, I have 45 minutes, right? About 45 minutes. Good, so I'm excited. I want to add so much more insights to you. So again, come to this talk after 45 minutes, you will be knowledgeable about what has happened in this last decade of 2,000 research papers on the field of refactoring. So in the second part, I want to talk a little bit about some of the work that my group has been doing and what are some of the new exciting fields that we have been working and developing. And in the last part of my talk, this is something that where I want to talk about some of the things that I found in my personal life, some of the lessons that I learned from my career. And I promise that this will add so much more value to you. So a lot of these lessons I learned the hard way, and I hope that you don't learn them the hard way. So I'm super excited, and that's why I structured my talk in 3 parts. I want to start with a story. On August 5th, 2015, I opened up my eyes, and in front of me there was a whiteboard, and on the whiteboard it was written, today's date is August 5th, 2015. This is the Good Samaritan Hospital in Corvallis. And I look around and say, why am I in the hospital? I had no clue how I got there. The nurse that came in the room said that I had a bicycle crash, which I didn't remember, of course. But she said I had a bicycle crash, and that's how I got in the hospital. I didn't remember any of that. My wife, I was very happy to remember my wife. I must tell you, I didn't remember important things. I didn't remember how many children I had, what was their birthday, what was their names. I thought that I'm still living in Illinois, because that's where we lived a few years ago. So I was really messed up. I asked my wife where I am, and she said, you know, you're in the hospital, you had the bicycle crash, which of course I don't remember anything about. And by the time that she finishes telling me all this story, you know, I completely forget everything, and I look at her in the eyes for the first time and ask, you know, honey, where I am and why I'm here. She said, I had a bicycle crash. And the ambulance found me and got me to the hospital. By the time she finishes this, you know, I go completely blank. I ask her again where I am. So at this point, she realized that something is messed up with my brain. You see, I suffered a severe brain concussion. And in this brain concussion, I lost my short-term memory. So my memory was resetting every 2 minutes. And if you have seen the movie My 51st Dates, have you ever seen that movie? It's about a woman who has a traumatic car accident, and her memory resets overnight, so she has to watch a videotape the next morning to remember the things that... but mine was resetting every 2 minutes or so. So what's interesting is that during the weeks and months of brain recovery, while my brain was healing up, I also had some of the clearest minds of my whole life. I could see my whole life. I could see how I was about doing things. I could see that I was very self-centered. I was very selfish. Should I say that I was very selfish and self-centered? It was all about me. It was all about me getting better. It's all about me doing the biggest, the greatest, the shiniest things. And it was less about others. So I reflected on that picture that I had, that very clear picture. Despite my fogginess I had, I said, this very clear picture of my life. And I realized that I want to change. I want to live a different life. I want to live a life of significance, which is not about me. It's not about only my personal success, but it's how can I take other people, how can I make other people successful? So that's the reason why I added this new content in the third part of my talk, where I'm sharing some of my personal lessons, and I'm so excited that you don't have to repeat those mistakes. Or maybe, you know, if you've learned those lessons but forgot them, like, you know, my brain was resetting and forgetting them, maybe, you know, when you hear them from other people, from someone like me and from my experience, maybe you'll get a better clarity of where your life is headed. Okay, so let's get started with the first part of the talk, with the landscape of refactoring. So what is refactoring? This is the classical textbook definition. It says it's a change made to the internal structure of the code that is meant to make the code easier to understand and cheaper to modify, to extend in the future, without changing its current functionality, without changing its current behavior. So how many people here in the room have done a refactoring? All right, let me give you some examples, and then I will convince you that every single one of you have done refactorings. How many people have ever renamed a function? If you work with a function that has a very poor name, and you renamed it so that you can better understand what that function is supposed to do? Oh, I see more hands. OK. How many people have had work with a function that was very long and complex, and in order for you to better understand, you had to break it down into smaller functions? OK, even more hands. So all of you have done refactoring. The other people who have not raised the hand means that you've never written any code, or you've never had to modify code. But if you had to deal with code, if you have to write code that you care about and you want to keep around, then you must have you must have refactored it. It's just that probably you never called it that way. So this guy, Martin Fowler, is the one who wrote this very influential classical textbook. It was followed by a couple of other similarly influential books, Refactoring to Design Patterns, and then Working Effectively with Legacy Code. So this was a phenomenal book by a guy who talked about how do we work with these very large pieces of code that nobody's around. The original developers have all left or died. Nobody's around to tell us what the code is doing. Right? So how do we refactor? How do we restructure? How do we keep make improvements in this piece, this very gigantic piece of code? So refactoring, it's extremely influential in industry today. So if you're looking at the top-level menu in modern IDEs like Eclipse or Visual Studio, anyone here is using Eclipse or Visual Studio or IntelliJ? Okay, so the rest are not coding. Probably the rest are using Emacs. What IDEs do people use here? So I see that not many people are using IDEs. Do you know what's an IDE? Do you know what Visual Studio is, right? So everyone heard about Visual Studio. So what are some of the IDEs that people use here in the room? Vim? OK, so you can think of Vim as a sort of, I would call it a very primitive IDE. But I think it qualifies for an IDE. What editors do you guys use? When you write code, what do you use for code editing? And for compiling and for debugging, for testing performance, for testing bugs, all of that stuff.
Code blocks.
Code blocks?
Yeah.
OK, who makes code blocks?
I don't know, but it's for C.
It's for C. OK, so apparently code blocks is popular for C. OK, anything else? And any other one that people have been using here? Yeah. IntelliJ, yeah, that's the number one in the Java world. So, a big proof that refactoring has made it up there is that if you look in the top-level menu, I think this is the top-level menu from IntelliJ. You see, you have the first top-level menu, it's File, Edit, and the third top-level menu, it's Refactor, and then you have this Navigate, Search, and so forth, and run the project and compile and build and all of that. So when the refactoring makes it on the top-level menu of all the major IDEs used in industry, it's a big sign of huge growth in industry. But today I don't want to talk about this. Today I want to talk about the refactoring research. And here I have a graph which plots about 2,800 refactoring papers that from its origin to about 2016. We have data also for 2017, but it's still in progress, so I didn't want to tabulate the data. So it's a huge growth of this field. Starting from one paper, which is not even tabulated here, is in 1990, all the way to close to 3,000 refactoring papers now. So in this talk, I want to look at what contributed to this growth of the field. Right, so before I do that, let me talk about the humble beginnings. So refactoring research started very humbly, should I say. The birthplace of refactoring research has been at my alma mater, University of Illinois. And Ralph Johnson, who is my former PhD advisor, was at the forefront, was the pioneer on refactoring. And the first ever refactoring paper was authored by him and by his, back then, his PhD student, Bill Opdyke. And then concurrently at Illinois and also at University of Washington, the first two PhD dissertations on the topic of refactoring came up. Right? And then my former colleague, Don Roberts at University of Illinois, he wrote the first practical refactoring tool that was extremely influential for the rest of the industry and contributed to this growth and adoption, huge adoption of refactoring tools in industry. And back then, when I talked with them again, I didn't do any research back then in the early 90s. But when I talked with them, they were telling me how hard it was the field. It was very hard to publish because people were always conflating refactoring with compiler transformations. So they say, well, a compiler can prove, usually does a lot of code optimizations under the hood and can prove the safety and will never do anything that it cannot prove. So the big question that these people had, the community had, can you prove the safety of those transformations? And that was completely not the focus of the refactoring community. Refactoring community was all about interactive transformations driven by the programmer, was not automatically done in a batch mode like the compiler does. It was a completely different workflow. So that's why people were so, the pioneers, the early refactoring pioneers were so misunderstood, because everyone else was saying, well, you sort of like you talk, about, changes in the code, it looks like compiler, but they are not like compiler. So it was very, very hard to publish in those years. As you can see from this, it was a while before we started to see. So there's a 2 paper, 1 paper, 1, 2, 3, 4, 5 papers per year, the first decade, look, it's just, about 1 to 2. At the end of the decade, we just got about, 4 or 5 refactoring papers in a year. And compare this with where we are right now at more than 300 papers, refactoring papers in a year. Right, so what I want to do in this talk, I want to look at this decade. And this is very interesting for me for several reasons. One is we sort of know what happened in so the community had, a nice big growth to this year, 2001, 2, 3, 4, 5. So up to this year, there is a famous influential research paper that mapped the whole landscape of what was happening at the refactoring community up to this point. But then there's nothing after this. So there's no other global understanding. And this is for me very interesting because we see a huge growth. Then we saw this big deep dive here in around 2010, 2011. And then we see a huge, sort of like almost like a second birth of the refactoring field with more than a doubling, almost like a tripling the number of publications then going from 2012 to 2013 and so forth. So that's why I want to give you a lens. If you can just take a lens and look at, and what we are going to cover today, it's about 2,400 research papers. This is, just put your seatbelt on, look at your neighbor, and say, buckle in because you are in for a ride. You just can you do that? Can you turn to your neighbor and say, just buckle in because be ready for a ride? Can you turn? So this is not hard. Turn to your neighbor and say, just buckle in because you are in for a ride. All right. So I see that it takes me like a few tries before people finally get the message. Good. So we are all buckled in. Okay. Let's get going. So what I want to talk about is some amazing piece of research that my colleague Maroon Casentini and his team at the University of Michigan have done. So this is a systematic literature review of what has happened in the field of refactoring. And I serve as a humble should I say, advisor or consultant, but they are the ones that when I say we, it means like, Maroon and his students did the actual work. I was constantly consulting and throwing questions at them and say, try this, look at this, what about that? But they are the ones who did actually the work. So we looked at Scopus and Web of Science, which are the primary repositories of indexed research, and this is what Thomson Reuters is using also for their ranking of computer science departments and programs and so forth. So it's also used in several other systematic literature reviews. So it's a very standard network of science. And we look for the keywords for refactoring that appears in the title or the abstract or in the keywords of the research paper. And we got about more than 3,000 papers. So then we narrow down and say, well, let's look and find out which of those are truly refactoring papers. So just the fact that they have a keyword, it doesn't necessarily mean that it's a refactoring paper. So we looked at this definition of the refactoring. Some papers about transformations that have preservations of behavior. And again, we, which means they, have done manually analyzed all these thousands of papers. So look at the title, look at the abstract, and sometimes they had to read the content. And there were 4 students. I should silence my cell phone when I talk. There were 4 graduate students who manually looked at all these papers. and try to categorize whether this paper was a refactoring paper or not based on this definition. And they had to reach an agreement. And in those cases where they couldn't reach an agreement, then the professor from University of Michigan, Marun Kesentini, was the fifth one who actually looked at the paper to decide whether it was a refactoring paper. So in the end, we had to remove about 400 papers from the corpus. So that's how we end up with about 2,800 papers. So first of all, we asked the question, who is publishing all these papers? Because that's thousands of papers. Right? We have seen from a very humble beginning to hundreds of papers per year. And we found out there is a set of what we call the highly prolific authors. So there is about 5,000 distinct authors, but not all are equal. So if you look at this set, people like my colleague Marun Kesentini and myself, and my PhD advisor Ralph Johnson. So if you look at the top 3 prolific authors in the field, we have between 33 and 40 refactorings paper. Again, this is a decade of refactoring work, right? So there's a bunch of other people who are still very prolific, and these are the top 25. So we end at about 13 papers in a decade. So it's about one refactoring paper per year for this author right here. If you look at how what's the productivity in terms of when we look at the whole big scope of things, so we see that these what they call the super top 25 highly prolific authors, they represent. So this is how many papers they publish in this decade, and this curve here shows what's the percentage of all the papers in this repository, all these 3,000 papers, all these 2,400 actually papers that we analyzed. What's the percentage of these papers analyzed by this, co-authored by this? So we see that when we get about to the end of the top 25, they probably publish around like 16%. So it's a very significant chunk of these 2,400 papers. Also, what's very interesting for me is that if we look at people who are publishing, so again, here we have about close to 4,900 authors, right? So if you look at how many papers they publish each year, right? And we look at this is probably a significant fraction. This is people who have published at least 2 papers. So about 23% of these authors have published at least 2 papers. And when we look at what's their contribution to this whole field, they publish about 68% of all the papers. So I say it's a wide community if you look at how many distinct authors we had, but it's also a deep community where we have these super top 25 here who are super productive, and we still have lots of other papers coming up from people who are moderately productive. Maybe don't have the main research topic as refactoring, but probably refactoring is a secondary or a third maybe a research topic for them. So look at also their influence, and again this here tabulates what they show here is the number of citations. So that's how we count influence in the academic field. Who pays attention to what you're saying, to what you're doing? So we have with these blue bars is the number of citations, and then with these orange bars is the number of papers that these authors have published. So you see people like myself or my co-advisor, my former PhD advisor, should I say, Ralph Johnson, who have both highly cited papers and also highly productive. But we also see people here like Sven Appel and Christian Kastner, who probably Eric who have published if you're looking here around 5 papers in this decade, but they're still very cited in the refactoring field. So those papers are very influential. So this was very surprising to me. Also, I look at the collaboration. So we see that this is a tightly knit community. So this shows who is working with whom at different institutions. And this is not surprising. You see that US is mostly working a lot in collaborating internally, but also with people from Europe. What's very surprising to me is that if you look from Latin America, we see very few edges of collaboration going to North America, but we see quite a lot of collaboration going to Europe. So that's very surprising to me. We also looked at where are these people located, and here we tabulated the institution from which we have this huge amount of research papers in refactoring. And sort of not surprising is that we have United States as the top. Maybe this also comes to when you look at other sciences. You see the United States as sheerly dominating the scientific community. Right? So this is the United States. But the second country is Germany, so still very productive in refactoring output. China is coming next at the third position, and then fourth, which is very surprising, is Brazil. I never thought that people in Latin America are so active in this community. To me, it's still, because this is the only Latin American country, and there's a bunch of other countries. Then we have again Canada, and we have Italy, and we have UK. So we have again, you know, what you expect. But Latin America, it's very present in the top 4. So where do they publish? Some, you know, here you cannot read, so I'm going to tell you some of these bars, you know, represent the number of publications in the major venues. And as you expect, you know, in software engineering, this is the premier flagship conference in software engineering, International Conference on Software Engineering. That's what takes number 1. And then we have International Conference on Software Maintenance. And then UPSLA, which is also a software engineering and programming language community and conference. And then it's a bunch of other conferences, and there's a, you know, this tail is very, very long, so we just didn't have space to tabulate all of it. But what's very surprising is that the second flagship conference in software engineering, which is Foundational Software Engineering, FSE, it's here, and compared to ICSE, which is its own sister conference, you know, much fewer papers are published in that conference. That's a very surprising fact. I cannot tell why. Let's look at the focus. So I told you in the beginning what's the definition of refactoring in the early 90s. Refactoring is a change. So if you look at what are these researchers doing now, refactoring, it's still about automating these changes. It's still about automating these changes that are part of these IDEs. But it's also about many other things beyond automating refactoring, beyond automating the changes. So one huge growth that we have seen over the years is the area of insight, automating the insight. So the insight is, where does the programmer know? How does the programmer know where in the code to refactor? Right, so if I'm an original developer, then I know that this is a very complex function that I often have to rewrite, or I often have troubles understanding. So then I use my domain knowledge, my experience. That's where I get the information. That's where I get, you know, the intuition for what to refactor. But we have seen over the years that a lot of people are starting working on automating the insight, and this makes sense because more and more code is maintained and is developed by people who have never written the code in the first place. So as code is growing older, as our code bases are more successful and the software is more longevity, then we see in several cases that the original authors have left the project, and there are other people who have to maintain and to evolve the project, and they no longer have that original understanding, of that domain, deep domain insight about what are the problematic parts of the code. So that's why a lot of the refactoring research community have picked up on automating the insight. Another one that we see a big growth is the testing. And again, this makes sense. It's the testing for making sure that these transformations are safe, that they are not introducing more bugs. And again, this makes sense because if you look in industry, people are mostly looking at, they are making this mental model. You know, if I make this change in the code to improve its maintainability, to make the design cleaner and better, then I have to reason about, am I breaking the code? Am I introducing other changes that are causing bugs? Right? How am I affecting performance, or maybe other things? Right? So it's all these trade-offs that I made in my mind. What do I gain versus what do I lose? So it's the cost of making the change versus ensuring that the change is proper and is safe. So that's why a lot of people have started work on testing. Prioritization, again, if you are recommending and you are giving insight to developers, sometimes you give them hundreds, on a code base of hundreds of millions of lines of code, like Microsoft Office code base. There will be hundreds or probably thousands of recommendations for refactoring. How do we prioritize them? Developers don't have the budget or the time or the patience to think about, or to even scan for these thousands of recommendations. Right? Also, we've seen some good growth on inference and recommendation, but those are the ones where we've seen most of the growth. What is the target of refactoring? So originally in the 1990s, refactoring was about changing the internal structure, was about changing the code. If you look at what happens in the refactoring community in the last decade, so code is still a high priority for change, but people have been looking now at changing models of code, changing the architecture of code, changing the database, the user interface. So this is also picking up some steam. So the community has expanded by looking beyond changes in the code and looking at changes in other software artifacts that have to do with the code. What are the target languages for refactoring? So Java, by far, it's the one that dominates, it's the one that dwarfs all the other ones combined. C comes on the second place, and then there's a bunch of other languages for the web, so CSS and Python and PHP. But as I say, Java dwarfs all the other one combined. So to me, this is interesting because if you look at what are the languages that are used in the development community, we see a slightly different picture. So I tabulated here based on Tyobe. It's a big survey company. It shows the popularity of these languages from 2002 to 2016, and you can see the top one is still Java. It's in decline in the last couple of years. But then if you look at this one, this is C, and this is C++, and now when we combine C and C++, they probably get to the same height as Java. Right? And if you're looking, so all the rest, most of the ones that are left here are essentially web languages. Again, if you combine them and you stack them on top of each other, they also come very close in popularity and in usage compared to Java. So this is where we see a huge discrepancy between what the community has been mostly working on Java and what the industry has been, has a much broader interest and impact. Okay, so what are the objectives? So originally the objective was to improve, in the 90s, was to improve the internal structure, right? To improve the internal quality, to make the software easier to read, to make it easier to maintain, to understand. We have seen a lot of growth in other objectives for refactoring. So what's very surprising right now is the internal quality. It's still there, but it's no longer the number one thing that researchers are automating. So performance, if you look at about 2010, it's when we see performance coming over the extent of usage of refactoring for the pure improvement in internal quality. So it makes sense again because performance is something that is measurable. It's something that you know whether you improved it or not. Whereas with this internal quality, if I change something in the code today and say, well, believe me, in a couple of years, this change is going to make the code easier to maintain or to read by other people. It's very hard. How do you measure that? It's such an esoteric thing, right? Whereas with performance, it's something that I can measure. If I make a change in the code that improves the performance, I can put my finger, I can measure it, I know exactly, end users feel it, perceive it. So it's in a way, it's not surprising that the community has moved on moving the objectives of refactoring towards things that are more measurable, that are more manageable, that are more tangible. Security is also have seen some growth and migration. So this is migrating between different programming models, between different languages. And again, security has seen some growth, but this is where I think the community can also grow a lot by, how can we, if we make a change in the code, do we preserve also the security characteristics, the security footprint of the code? What's the implication on that? So I think that's where the community needs to grow a lot still. Which techniques people have been using? So the bread and butter is static and a little bit of dynamic, but mostly static analysis. So this is still the huge focus. People are using, common representations are abstract syntax trees that compilers are using. A lot of this static analysis is using some control flow analysis, and some of the more sophisticated ones are using probably pointer analysis or other data flow analysis that are going more in depth. But by far, we have seen that static and dynamic analysis is still the number one tool of choice when people are automating or are doing this research. We see a couple of new risers. So search-based techniques that are using genetic algorithms and other heuristic searches. Especially people in the model community, where they are looking at predicting, where they're looking at giving recommendations. So they are using a lot of these search techniques. Data mining is also, have seen a huge increase in the field. So people who are, again, looking on repositories, who are trying to give insight, who are mining software repositories and are trying to come up with insight and with recommendations. They are using a lot of data mining techniques. In terms of how do they evaluate the work, if you look at the top one, actually even before the top one, if you look at the number one most preferred way to evaluate this work is empirically. So analytical evaluation, which is more common in programming languages via proofs and so forth, it's less used in this community. It's mostly empirical analysis. And here we see open source data. It's still the number one source of empirical evaluation. So people are doing some refactoring. They're applying on an open source code base. In some cases, maybe they send some patches of those refactorings to the original developers and see how they respond, see how they interact. We have seen also a rise in industrial data. So here we've seen 3 levels of sorts of evaluation that people are using. So the level 1 is surveying with practitioners, finding out what are the needs of industrial software developers. Then we see the people who are going beyond that and are validating their code on industrial code bases. And then we see the people who go, at the most length, people who are licensing, refactoring technology to industry, people who are moving beyond, going the extra mile, and they are using their tools to the point that they are mature and they are solid enough that they are incorporated in official release of these IDEs or in other software products at companies. So personally, this is where I would like to see more grow also in usage of industrial and working closely with industrial practitioners, because really that's the test. That's the test of whether we are doing something that changes the state of the practitioners. So I had the question, we asked the question, what happened in that, if you remember that big growth from 2012 to 2013, so if you remember this, like you remember this big dip here? So we looked at what happened here, what contributed to this huge growth. And these are some of the things that we have seen. So we have seen, compared to 2012, a huge growth of the work on models, so refactoring and changing and giving insight on models. We have seen a huge growth in areas such as giving refactoring insights and refactoring opportunities, and also in domain specific, so architecture refactoring, and also refactoring for parallelism, for performance. So if you look at the original definition of refactoring, it was given 20 years, 10, what was that? About 20 years, not quite 20 years, so we are probably around 17 years ago, by Martin Fowler, that this is a change made to the internal structure of the code to make it easier to understand, cheaper to modify. We have seen that as, the field, actually most of the growth has come from expanding this definition. So researchers have looked more beyond simply automating the change, but more looking at, giving insights, recommendation, prioritizing changes. We started to work more improving not only the code, the structure of the code and the code itself, but improving other artifacts such as models or architecture or the user interface or the database model that is using the software. And the objectives have been moving now beyond just improving internal quality. Has been a lot of growth has been in the area of improving performance and other non-functional, so security and usability and other non-functional requirements, while still maintaining and keeping the functional observable behavior. Okay, so let's see how we're doing with time. So about 10 more minutes and then we can open for Q&A. Okay, good. So let me just give you a quick flavor of some of the work that my group has been doing. How many people have a smartphone with you? Are using currently a smartphone? Oh, so I'm in the right room. Good. Good. So smartphones and the apps, the app ecosystem has seen a huge growth. So this year alone, it's expected about 300 billion apps have been downloaded. And what really plagues these mobile apps, the number one problem with this is slow operations that freeze the UI and frustrate users. Right? So kind of sort of like freezing the UI, like my UI has been frozen right now. So how many people have ever got frozen UIs on apps? Okay, and that's very frustrating. So a recent paper found that about 75% of all the performance bugs in top-rated Android apps come from these frozen UIs. So the question is, what makes these UIs frozen? How can they get frozen? Why do apps become frozen? So they are all using all these programming models that we are using today on mobile technology are all using an event model, which is, think about it as all these events that we generate, like when we are touching the screen, when we are changing the orientation of from horizontal to portrait mode, when we are moving physically, the GPS and accelerometer and all these sensors, they are collecting data and they are generating these events. And there is one event queue, which is the main queue. So here I'm simulating what happens when I'm touching on a button on the user interface. A new event is generated on click and it's put on this event queue. And there is one UI main thread which takes these events from the event queue and processes them one by one sequentially. So this is what can go wrong. Suppose that we take one of these guys and we are processing it now, and this event requires some access to a slow resource, for example, access to a cloud or something else over a slow network. So while the UI thread processes this event and waits from the reply from the cloud, essentially it's frozen. It cannot accept any other events, any other things that we do, are not going to be serviced by the user interface thread. And that's when we get these UI frozen screens. So the technique is to fetch this long-running slow computation, and instead of running it in the UI thread, to run it in the background as an asynchronous task. So we're going to take this long-running operation, run it on the background. When this has finished, we get back, we have to register a callback, and we get notified back in the main UI thread that the result has been available from the cloud, and we can start display it and process the results. So there are several. This is the domain, this is the model of working with asynchrony. It's well understood, but there are several problems. One is that moving from synchronous to asynchronous, this is not an easy. It's a different programming model. It's no longer you call a function and you get the result immediately, but you have to think about that you call a function and you have to register something else, a callback, to get notified. So it's very different. On some platforms, Microsoft no longer supports old legacy style of asynchrony, so you have to go and change the code to upgrade to the new. And again, these are non-trivial. You have to preserve the program behavior, the functionality of the code, even the order in which exceptions are thrown. So there are even more perils ahead. So once you are in the landscape of asynchronous programming, you have to worry about how do I make my code performant. Right? If you're not careful, you can use asynchronous programming to hurt performance. You are not gaining performance. You are hurting yourself. So we found out that about 4% of the supposedly async code in top-rated Android apps not only has the syntax of asynchrony, but instead the code still runs synchronously. We also found misuses where people, instead of doing it judiciously, they are using asynchrony, and they are badgering. They are sending so many more interrupts to the UI that actually, rather than improving response, it kills responsiveness. It's the proverbial death by about 1,000 paper cuts. We have also seen other problems. We have seen when people have to convert from one model of asynchrony to this other model of long-running, from short-running asynchronous tasks to long-running asynchronous tasks. We have seen, again, if you do this, if you are not careful, you can actually hurt the performance. You can have memory leaks, lost results. You just wasted energy bringing and fetching something from the cloud which you cannot display. And again, this requires changing in the code, requires very dramatic changing in the way how you work with this asynchronous code, from shared memory communication via shared variables to almost sort of looks like a distributed style of programming where you are using message passing and you have several channels on which you are passing information and you're broadcasting to a set of receivers the passing of the information. Right. So my group has been automating several of these vectors of change. So going from synchronous to asynchronous, because we've done this for Android. Also, we've been working a lot in the .NET landscape with Microsoft products. And unfortunately, I do not have time to talk about any of these. I still have about 5 minutes, and I'm looking forward to the most exciting part of my talk. So I wouldn't have time to go into any of these details, but this is just a very high-level overview of what my group has been doing over the years. OK, so let me skip ahead to, I said this is the most personal part of my talk. This is the one that I'm most excited about, because this is where I talk about reflections and lessons I learned on my career. And some of the lessons I learned the hard way, and I hope that you learn them the easy way. That's the best way to learn from someone else's mistakes, not from your mistakes. And this is where I want to add so much more value to. Again, this is the sort of stuff that 2 years ago I will never tell you about this. Why would I want to be successful? It was all about me. If I tell you how to become successful, you are going to be successful. I'm going to be less successful. But today I have a different mindset. Today it's all about how can I make other people, how can I move beyond my personal success. How can I move into significance where I take others and let other people build and climb on my shoulders so they can do better, they can go further, they can do more than I was able to ever do on my own. So some of the lessons, I organized a series of 5 lessons. We'll see how much time we have to go through this. Maybe I'll cover like 3 of them. work in your strength zone, but reinvent yourself. So I've been working in the field of refactoring for about 15 years now. And you ask the question, don't you get bored if what you're doing is refactoring? And people do get bored, and people do get indeed. So this was my secret. So I started working on library migration. This was my PhD dissertation. It took about 5 years. So I was working on how can we change the interfaces, the APIs of frameworks and libraries without actually breaking all this code that depends on them, and how can we transfer those changes from framework from library to client code. Right, so I learned a lot. I used a lot of deep static analysis. And by the time that I finished my PhD, I thought that I was very competent. I thought that I learned a lot. And then parallelism and concurrency came around. So my interest now has shifted to still using refactoring to take sequential code and make it more thread safe, to improve the throughput, to improve scalability of already existing parallel code. So I've been working for about 5-6 years in this area when people stopped using in mass laptops and desktops, and all the end users have switched now. So my parents no longer even own a laptop or a desktop. All they have is iPads and smartphones, right? And then in that area was how can we make synchronous slow code more performant, more asynchronous, right? So this is the secret. I stayed for all these years, for 15 years. I've stayed in my strength zone. So my strength zone is static analysis for changing code between different programming models. But I constantly reinvented myself. I constantly changed my center of gravity from this area to that area, from this area to that area, where I learn more, I stretch more, I grew, I learn more. Right? So that's how I never got bored, because I was always learning something new. Although all this time I stayed in my strength zone. And there are times when I try to dabble and go into other things, but I was less successful. Okay, find your dream and then live it. So a lot of this has been about what do you truly, really want to do. So for me, the deepest thing that I care about is having a practical impact. And I'm saying this to you, and I'm going to give you a lot of practical examples of my practical impact, not to impress you, but to impress upon you that you must find what is something that you are truly passionate and pursue it at all costs. So some of the work we've done on automating ships now with official IDEs like Eclipse and Visual Studio and NetBeans, send hundreds of patches. Some of the work on inferring refactoring is used at big companies like IBM and Google and many other research labs. The work on testing infrastructure for refactoring is used now in the official products at Oracle. Understanding refactorings and transformations have shaped the official release of APIs in Java and in .NET in the concurrency landscape. Right? So all of this is not to impress you, but to impress upon you that this has never happened by chance. It was always by design. It was always that was my end in mind. I knew that that's the kind of stuff that I want to do, which required work beyond just publishing a paper. And I was very proactive in making those things happen. Okay, so I'm going to skip over this and skip over this. And then the last one that I want to talk about, which is probably the one that is most important of all of these, is this question of how do you grow yourself? You cannot give to others, you cannot do to others what you don't have inside. So the most fundamental question for me was, how do I become better on the inside? Before I see this productivity improvement on the output, before I see my students working better, how do I grow myself? Right? And this is what I want to challenge you. Do you have a plan for how you get better? Do you have a plan for how you get better as a person, for how you get better at relationships? None of this thing happens by accident. I used to think that if I just live enough, long enough, I'm going to learn from people, I'm going to be stretched by events. It has not happened. So now what I'm doing, I'm joining myself and surrounding myself with a group of other faculty, and we are all going and studying growth and are intentional about growth. And this has made a huge impact, has made a huge difference in my life and also in the life of those around me that we all go through. We read books together, we challenge each other, we keep each other accountable. It made a huge, it's a game changer. Okay, so my most important investment in growth, it's been my students that I've been very fortunate to work with. So a bunch of PhD students and graduate students and here undergrads who have worked with me. And this is my summary concluding slide. I sort of gave you a very quick tour de force of refactoring, about 2,400 papers in the community and And we looked at some of the lessons that I learned in my career, and this is what I want to open up for. Maybe we have a few minutes to ask some questions. If people want to ask questions, I will be staying at the end if you want to ask me more questions. Yeah, thanks a lot. Okay, who wants to ask the first question? Yeah.
You say working your strength zone to reinvent yourself. What does that look like practically? So how do you find new areas that aren't too far out there but also aren't too close to home?
Yeah, so how does it look practical to find your strengths? The first thing that you have to be aware what are your strengths. So do you know what are your strengths? Do you know what you're good at? Like the first thing, that's discovery, that's awareness. And then the second thing is investing, so you're growing the skills in that strength area. I'm learning new skills all the time, but I'm staying there. So when I try to get out of that strength zone and work on things like human-computer interaction or other things that are not in my strength zone, I mostly fluff and I mostly fall on my face because that's not what I'm good at. Right? So if you find out, if you discover what you're really good at and stay and stick with it and develop strengths and develop skills in that particular area, that's how you become successful. You're not successful by becoming an expert at everything. People who try to be expert at everything, they just become mediocre. They are not good at anything. So we really excel when we really find and become aware of what's our strengths and when we develop those strengths. Excellent question. Another question, maybe? Yeah.
Stop. If you need to leave, please leave, but do so quietly. While you're still here, just because you hear people leaving doesn't mean you can start a loud conversation. So please drop down the level of conversation. Thank you.
Right. Do we have another question? Who wants to ask another question? Oh, okay, over there in the corner.
So the refactoring that's done, is it in terms of actual doing it on a code base? Is it done through direct interface on the part of a person? Is there automated algorithms that actually use standard code? What you've done research on? What is, I guess, just some basic information.
Yeah. So who triggers this process? Like, how is it done by humans, or is it fully automated, or is it somewhere in the middle? So most of the work and most of the work that has been practical and applied and was very successfully adapted is interactive. That's been studied by the humans. So the humans use their domain and insight and knowledge and intuition. There are people who have worked and expanded the frontier of doing it fully automatically, where they take your code base, mash it up through a sort of genetic algorithm, which try to come up with a better optimal structuring of the code. And while they can measure with some metrics that this structure of the code is more modular according to some metrics, people usually in practice never use those solutions because they don't have any ownership. The code is so differently looking from what they are used to, and the changes are so big, are so drastic that people are not adopting those changes. So how do you find that balance where the owner is still the human, but you can help the human rather than replace the human? How can we help the human to give some insights and then let the human to use his decision making to judge whether the recommendation is something that makes sense or doesn't? So I think that's most of where we see practical impact and best areas to grow the field. Good, excellent question. Someone else wants to ask another question. I know that you are here, and then you might be leaving home and say, "Gee, I just wish that I would have asked that question." So, because if you don't ask it, you'll wake up at 2 a.m. like what I usually do. Wake up at 2 a.m. and just start thinking about. So, I want you all to sleep very well tonight.
Hey,
so,
let me suggest that we finish the official question.
Sure. So we can also do that. So let's finish the official part and